and we are making that transition. So everybody, we are going to be recording on YouTube and broadcasting live on YouTube from this point forward. So if you do not want your voice or your face on there, you can either watch us on YouTube or you can stay here in Zoom and just keep your video and your audio off. And you'll still be welcome here, and you can still put things in the chat room. And if I miss things in the chat, guys, let me know, because I get busy sometimes and miss things in the chat room. Okay, hello everybody and welcome. This is the Southwest Florida TechNet. My name's Ian Hicken, KO4EFS. And I got to tell you, I'm coming up real close on my 1-year anniversary. I got my ticket just almost a year ago. And I am just really having a great time with ham radio. And I got to tell you, tonight is going to be probably my favorite net so far. It's going to be the topic that I've wanted to do for a long time. So let me just get a few things out of the way before we go any further. The Southwest Florida TechNet, you can get us at SWFLtech.net. If you want to join the Zoom meeting, it's open to all amateur and potential amateur radio operators. You can go to www.swfltech.net at any time and join the Zoom meeting. And I'd like to welcome anyone who is watching out there on YouTube. The YouTube chat room is not necessarily being monitored, so you will need to come into Zoom if you want to chat. I'd like to welcome the 18 people that are in Zoom so far, and I'm sure that number will continue to go up as people check in. Friday night's a rough night. I get off work at 7. I get here about 7:15, and I try to get this turned on at 7:30 so that the Gab Fest can start on time. It's a bit of a rush for me. But I am here, and we are on the air. Later on tonight, towards the end, after we get done with the solar discussion, I am going to talk a little bit more about the Magic Band. I've had a blast with the Magic Band, with 6 meters. The sporadic E has been absolutely amazing. I've made over 400 6-meter contacts now, and I am just absolutely having a blast with it. It's one of the funnest things I've done. When you add FT8 to chasing the Magic Band with a directional antenna on 6 meters, the strategy level is to the point that I'm just having a blast. I can't get enough of it. I'm literally depressed at night when the band lets go about 10 o'clock. I'm like, it's going away. Anyway, so I got to tell you guys, having a blast with it. So we're going to talk about that later on. But I want to ask if there's anybody that has any announcements or anything they want to say before we get started. Come now. Okay.
Can you hear me?
Yeah, I can hear you. Go ahead.
Do you have video on me? This is Bob, KD8SYP.
No, I don't think we see Bob. No, we don't got, no.
What's the magic in the laptop to turn on the video? It used to work all the time.
But down at the bottom of one of your Zoom screens, there's going to be a little microphone and a little camera, and you just click that little camera. If that doesn't work, there you go. Hey, Robert.
Thank you very much, gentlemen from Ohio.
All right. Well, there you go. We won't hold that against you.
Thank you.
I'm just kidding. We've got to bust everybody's you-know-what when they first walk in. Yeah. No, I'm just kidding. All right, well, we are really glad you're here. We're glad you're here, and everybody from all over the world is welcome. That's the one thing that the Zoom meeting has afforded us, is the ability to talk to everybody all around the world. So that's awesome. If there's anybody that's not muted, if you could mute, I'm hearing like a baseball game or something. It's real light, but it would just help me out. There, it's gone. Thank you. So you guys are awesome. All right. And I don't care if you multitask, because I'm a multitasker. Don't make me rude. Okay. So anyway, tonight's discussion is going to be one that I've been wanting to do for a while. And this week, thanks to COVID and all the exciting hour restrictions that it's been putting on my 3 jobs, I had a lot of time this week. And I finally did it. I finally put the finishing touches on what I think is probably going to be the most amazing PowerPoint presentation you're probably ever going to see. And I hope you guys enjoy it. I have really put a lot into it, because I think that one of the things that is probably more underestimated than literally anything else when it comes to when it comes to amateur radio is the relationship that we have as amateur radio operators with the sun and with the space weather environment. And I don't think a lot of people really get it. And so I've been wanting to do this for a while because this is something that's been an interest of mine for a long time, long before amateur radio. Back when I was a teenager, I used to read about space weather, and it's just been an absolute interest of mine. And so I'm going to run through this. It's probably going to be a long one. If you guys have to duck out, I won't hold it against you. But I want to make sure that we cover all the bases on this, because especially if you're on HF, this affects everything you do. Every single thing you do is affected by this. And so it's so important that as amateur radio operators, that we understand the relationship that we have with the sun. And if I get to somewhere that you know more than me, please step in, because you probably do. Okay. I'm going to run through this. I've got some neat slides of a bunch of different stuff in here. And so to start with, what we're basically going to be discussing tonight is the solar basics. This is something that's lost on some people. They're not sure what is the difference between a coronal mass ejection and a solar flare. Well, tonight you're going to find out. Sunspots, coronal mass ejections, our geomagnetic field, effects on the amateur radio transmissions, the Carrington event, which I'm going to go into a little bit of detail with the Carrington event, because this is a one in 500 year event that we might see repeat itself. Solar and space weather web resources, and we'll get to that towards the end. You know, when we're talking about space weather and we're talking about the relationship that we have in this solar system with our sun, it's amazing. Our sun, it provides everything to us. And it also is lethal to us. It's absolutely lethal. When it goes off, it's like a bomb. And the only thing that protects us is something right out of Star Trek. It's our deflector shield. It's this amazing thing that's created by the weight of our iron core. It's actually created by the planet. It's a science that we don't even fully understand, gravity and how it works, and how this gravity well goes around our planet and protects us from everything. It repels things, it repels energy, and it converts things into forms that are not destructive to us. Our magnetic field is absolutely one of the most amazing things in nature, and is taken for granted. Our sun is potentially lethal to everybody in the solar system that's not protected by a deflector shield. And that's basically what our planet looks like out there every day, with our shields up at red alert, because the sun is constantly fighting us, trying to kill us, and it can't get to us because of our deflector shield. And I just think that's some really cool stuff. Basically, when we're talking about, whoops, let me go back here. I'm still hearing myself back somewhere, and I don't know where that is. Hold on. I think it might be over here. No, it can't be there. Oh, I know where it is. Hold on. Give me just a second, folks. Hold on. I'm sorry. I have to know this out. It's absolutely killing me. There we go. All right. 50 clicks later. There we go. All right. So anyway, basically there's different kinds of storms that we get from our sun. The first one is a solar radiation storm. Warnings are possible, but they're only going to come in minutes. Did I skip a slide here? I did. Okay. I'm sorry. Solar flares. These are the first ones. When these happen, when solar flares happen, it's a sudden burst of energy from the sun. There's no advanced warning. These come in at the speed of light, which, you know, is like 4 minutes. It's really not a lot of time. The effects usually last tens of minutes. They're high frequency, and they generally impact the sunlit side of the earth. If it's significant enough, it can affect frequencies as high as VHF and UHF. This is the first indication of something bigger, which the next one would be a solar radiation storm, Warnings are possible on these, and I'm going to show you why the time scale is so important on this stuff in just a minute. I've got a great graphic for that. When we're talking about a radiation storm, warnings are possible because we're talking about minutes now, maybe up to an hour or two. Effects can persist for several days, and it's effective to our satellites and our people that we have up in orbit, and it also causes HF blackouts in polar regions, but not as much effective on us. But then we have the geomagnetic storm. This is when this energy from whatever form reaches the planet. Once that energy reaches the planet, now this slower energy that comes later creates geomagnetic storms. It comes and it arrives in a day or two. We actually know this is coming. There's actually predictive maps that we can use to kind of see when we're getting this slower moving energy that creates these storms. They can last for a day or two. Power grids and operation stability can be a problem. And they also create maximum usable frequency depression, meaning that your MUFR, your maximum usable frequency, will drop during one of these events. Global navigation satellite systems are a problem. And of course, they create things that are on my bucket list. The aurora, I've never seen one. You know, it's amazing to see how few of us have seen the aurora borealis, and it is one of this planet's amazing beauties, and we'll get to that here in just a few minutes. But aurora is sometimes referred to as the polar lights. You know, we always hear aurora borealis. Do you know what that means? Well, their polar lights are called aurora polaris. The northern lights are aurora borealis, and the southern lights are aurora australis. And so depending on where you're seeing them is what kind of lights they are. So I just thought that was kind of interesting. Aurora, although it should be aurorae, most people say auroras, and it's accepted, is a natural light display in Earth's sky, predominantly seen in the higher latitude regions. Auroras are a result of a disturbance in the magnetosphere caused by solar wind. These disturbances alter the trajectories of charged particles in the magnetosphere plasma. These particles, mainly electrons and protons, precipitate into the upper atmosphere, resulting in the emission of light. And man, I'll tell you what, the varying patterns and colors of these lights is absolutely amazing. Like I said, probably one of the most beautiful things in nature when you really go look at it. This video here is sped up a number of times. They don't actually look this fast. Look how fast the cars are going down the highway. But if you've never taken the time to just look at the beauty in an aurora, it is absolutely amazing. And when you think about what's going on up there, that's our deflector shield literally absorbing and reflecting deadly amounts of energy every second. And it does it in such a beautiful way. And you know, it's funny because when you watch Star Trek, you always see the phaser hit the ship, but it hits the shield around the ship. And you always see the shield going, brrr, and you can see the shield struggling against the phaser beam. That's what the aurora is, literally, our shields struggling against the phaser beam. That's what it is. And I just absolutely think auroras are some of the coolest things in the world. So there you go. There's my little trip through nostalgia there. I just absolutely love auroras. Coronal mass ejections, probably the biggest threat to man, bigger than nuclear war, bigger than the gray aliens, which I think the grays are probably most interested in us, but that's for another night. But bigger threat than anything in the entire world. You're more likely to get killed by a coronal mass ejection than any other kind of huge disaster. And that's because this hurls such an amazing amount of energy into space. And then if our planet runs through that energy, it can be a real mess for us. And basically these originate from active regions. You'll have magnetic fields and you'll have plasma riding over the top of magnetic fields, and next thing you know, there's a collapse, things fall in, things splash out. It's pretty simple when you look at it. It's some amazing stuff. In the solar maximum, the sun produces about 3 CMAs a day, CMEs a day. Think about that. 3 coronal mass ejections a day during the peak of the 11-year cycle. In the slow part of it, in the minimum, they only get one about every 5 days. So you can see there's a drastic difference between the top of the cycle and the bottom of the cycle. So just amazing there. And basically, a coronal mass ejection is when a large amount of the stellar matter, the star material, the plasma, whatever you want to call it, that hot stuff, splashes out. And when it does, it's going to destroy anything in its wake, unless, of course, we have our shields up. It's going to go right by that first planet, no problem. It's going to go right by the second one. They're not really affected that much. It's a rock, no big deal. But by the time it gets to us, and we're talking a day and a half later, you know, they all travel at different speeds. And one of the predictive things we have to do with these things is how fast it's traveling towards us, okay? By the time it gets to our planet, we're the first one that actually has a pretty good sized deflector shield. And we put up quite a fight. But here it comes. Anyway, our planet has this magnificent electromagnetic field that actually, when these waves of energy come in, they actually take that energy and move it around the planet. And by doing that, a lot of it actually comes into the poles. That's why that's where the aurora are, the aurorae, if you will, are most predominant, is in the poles, because that's where the energy, then when it backlashes, that comes back and that gives you your night side auroras, which is really cool. And so there you go. There's your auroras caused by all that energy that had to be reflected by our deflector shield. So I just think that's absolutely amazing. And maybe I'm just simple. Coronal holes. One last thing on this, and we're moving on. Coronal holes. This is something that when these happen, they can last for several rotations around the sun. They happen during minimum, they'd happen during maximum, and they do spew out a lot of energy into space, but they're nothing on the scale of the other things we've talked about tonight. Do these affect radio waves and our ability to transmit? Absolutely. You can get a nice wind stream coming from a big, huge coronal hole like this one that's shown here, and it can be geoeffective here and attenuate our geomagnetic field to such a point that it really affects stuff here. So yeah, absolutely. Even though they're not big events, you know, they're tropical storms to the other hurricanes, but it is what it is. Now, when will it arrive? This is the big thing. This is what people don't understand. Well, they said, well, there was a flash on the sun and it blocked out the radio transmissions over the Pacific for 8 minutes. But then they said it's going to cause auroras 3 days from now. Well, how does that work? Well, here it is. When something happens on the sun and it puts out a bunch of X-rays, those arrive at the speed of light. Okay. So we're talking minutes, 4 minutes, give or take. I don't know the exact measurement right now. So this comes on very fast and then it dissipates out. Okay. Radio waves, again, coming in just about at the speed of light. And they're going to come in relatively fast, and they're going to, radio blackouts do take a little bit of time. They're going to dissipate a lot slower than the light stuff did. Then you got your energetic particles. They end up arriving an hour later. They're not traveling quite as fast. When that arrives, they can also be geoeffective as well. But the solar plasma is the one that actually creates the biggest solar storms. And notice it's traveling much slower than the speed of light. It can be traveling very slow, actually, and take 2 days to arrive. Other times it can arrive in less than 1 full solar day. So it all just depends on how, when we look at it, you know, what we've got coming in, how fast it's going to arrive. And that explains why a single event can have actually 3 or 4 different times of arrival for the different types of energy that's coming in at different speeds. Why know about space weather? Our sun has an enormous effect on not only our climate, but the upper atmosphere that surrounds us and protects us. Knowing about space weather and the layers of the atmosphere help us to understand radio propagation and radio blackouts. You know, I actually witnessed my first radio blackout on my FT8 waterfall. I was on 20 meters. I had a full waterfall. I've split my audio into a second computer where I have a big full screen waterfall so I can see like the last 20 minutes. And I'm watching this thing, and all of a sudden, within about 3 minutes, it was gone, to the point that I'm climbing my tower because I thought my wire must have cut loose up there. I check everything. I can't find anything wrong. I'm figuring, okay, something's grounding out my wire. I can't find anything wrong. I switch over to my ICOM thinking something's wrong with my FT100. Same waterfall. I'm like, what the hell's going on? And sure enough, later on, I find out it was a radio blackout that was caused by a solar flare. And so sure enough, I actually got to witness my first one. I wish I was recording the screen so I could show it to you tonight. But let's just say the waterfall for a very active 20-meter FT8 went completely blank for about 7 or 8 minutes. And then over the course of about 4 additional minutes, it was back at full strength, and I'm talking all over the place again. Wow. What a cool thing. I mean, it literally affected my entire ability to communicate. Now, of course, it was not that strong, so it didn't affect the upper bands, VHF, UHF. But man, it had a hell of an effect on 14 megahertz. So I thought that was really interesting. When you're on HF, you want to, obviously it's important, especially if you're doing the low power stuff. The lower power you want to run, the better you have to have, the better environment, the better antenna, the better strategy, being on the right frequency at the right times. And we're going to go into some of that later on too. What is the ionosphere? It's layers of the Earth's atmosphere that range from 50 miles to 300 miles high. It's an area of charged plasma consisting of ions and electrons that carry current. It would be an electrically neutral if it wasn't for the UV radiation from the sun. So once again, we would get zero propagation from our ionosphere. Our HF radios would be useless if it wasn't for the effects of our sun. The more radiation that impacts it, the more reflective it becomes to a certain range of electromagnetic energy. In other words, frequencies, a certain frequency. Layers of the ionosphere. This is really cool. This is something that I didn't really realize till I was studying for this. These things are like mirrors, these layers in the atmosphere. They're like mirrors, but they're like the mirrors that you see in a fun house. They kind of reflect different ways. They reflect a lot over here and a little over there and not really right over here. And so you got to kind of look at it that way when you're looking at this. The neat thing is the left diagram is daytime, the right is night. And you can see there the sporadic E is the dark blue. And that of course, the sporadic E is its own phenomenon that doesn't have a lot to do, as much to do with the sun. It has a lot to do with movement of air, and it's not totally understood. And we'll get into that later. But you could see during the day, as it comes down through the layers, it creates reflectivity surfaces that we are able to then bounce our radio waves off of. At night, the two F layers combine into one big F layer at night. And then, of course, sporadic E can continue on into the evening. I've seen sporadic E run till midnight. So it doesn't necessarily mean it's going to shut off just because the sun goes down. I've seen 20 running later than normal lately, and I've seen 10 running later than normal lately too. So I think it's just something going on right now. Everything seems to like run later in the evening. Could just be more people awake. I don't know. Variations in the ionosphere. You know, there's so many things that greatly affect our transmissions of our radios that we don't realize. Number one, day, night is where you're calling in a day and your night, or vice versa. You know, that makes a difference. Seasonal, hot temperatures in the summer tend to energize the atmosphere and warm up the layers, creating static and pushing the layers up to higher altitudes, which actually give you longer jumps. excuse me, allergy. Your geographical, the location of the landmass and height, sea level will greatly affect propagation, both positively and negatively. I always thought it'd be cool. I'm gonna go set up my rig. Once I get my portable rig ready, and I'm all set to go operate, I'm gonna go up to a place called Buck Bald in Tennessee. It's the top of a mountain that's completely bald, and it's like a park up there, but it's not advertised, so there's hardly anybody up there. And I can go up there and set up antennas and wires, and it's literally almost it's right at 6,000 feet. I want to go there and try it from there, and then I want to go out to an island somewhere and try it from there. I always thought that what a great place would be. You know, so that just your geographical location has a lot to do with how your radio propagates both near and far. Cyclic, because of the effects of sunspot cycle, propagation will vary every 11 years. And of course, as you guys know, last year was kind of the bottom of that, and we're starting to work our way up the good side now. Everybody tells me, you picked a good time to get an amateur radio. You got 5 years to study before it gets really good. Propagation prediction. Everybody sees this thing, right? You see this on every website, right? But yet none of us really want to admit to each other that we don't exactly know what all this crap means on this thing, right? I literally had to go through it myself to make sure, because even though this is kind of my thing, there's a lot of stuff on here. And so I'm going to point out a few of the important ones, what we need to know, and kind of give you some basic ideas. I want you to know the first thing about this thing. This does not tell you what's going on at your house, in your state, or even your country. Most of this information, some comes from Boulder, some comes from other stations around the country. A lot of it comes from Europe. Okay, so when you look at this thing, you can't go, oh, crap, the band's closed, I'm going to bed. Don't do that, man. I'll tell you, when it says all the bands are closed, I go turn the radio on because something's going on. And I'll find a good band. That's when the atmosphere is doing something crazy. And that's when you really want to get in there. So it only gives you an average of what's going on. And the average is sometimes based on multiple sites, but it's not your site. So don't ever get too discouraged by these numbers. But when something's going good or going bad, pay attention to what these numbers say at that time so you can compare it next time. Solar flux index, one of the more important ones that I think is important here. And I don't know if I can, I don't see it. Well, I think, can you guys, I don't know if you see my mouse? Yeah, you can see my mouse. It's good enough. They got like a red dot thing on here. That's pretty cool. But okay, anyway, over here, the solar flux index is this top number right here. First thing you want to do when you look at this on a website is look at the top and make sure that you're looking at a new one. Sometimes they don't update right, and you want to hit Shift F8 or Shift and hit refresh, or Control and hit refresh, depending on your browser. Make sure you got the fresh copy. A lot of times you'll look, it'll serve you the one from yesterday. So make sure you got the one from now. It should be no more than 6 hours old. And remember, the times are Zulu or Greenwich Mean Time or standard time, whatever you want to call it, international time. Everywhere I work, they called it something different. Solar flux index. If it is greater than 90, that's heyday time. I've yet to see it greater than 90 since I've been doing this on HF. We got close. We got up to 87 one day, and it was really cool because everything was open. It was running good. So you want to watch that solar flux index. When it gets down in the 60s and 70s, 70s and low 80s, is going to give you more of a normal type day. 60s, I've seen it where a lot of it's kind of shut off. So, you know, you're looking for that to be high. You want that to be 90 or higher. Sunspot numbers. Well, that just tells you there's a bunch of stuff going on. You know, it doesn't really give you anything specific, but if you see that sunspot number is at 2 or 3, that's pretty cool. And the muff is that's not a dirty word from the 70s. The muff is the maximum usable frequency, and it varies based on location. Now, looking at this thing, you can see there's your solar flux index and your sunspot number right there on the top, number of sunspots. Okay. The next thing you really look at, the rest of this stuff's cool. And if you guys want to go in and learn what each of those mean, they're great. I'm not going to play Bill Nye the Science Guy and try to explain each of those to you. So I will tell you that when I get down to the HF area here, the HF conditions, I look at that. I don't use that to decide whether I'm going to go on the air or not, but I like to use it to let me know something's going on. If I look at these and they say poor, 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 all of them are poor, something weird's going on. And I usually can find somewhere where I can find a niche, because remember, when all the bands are closed and nothing's going on, everybody else is out there looking for a hole too that's open. So go out and look. There's something open somewhere. It's never, I could be wrong. And some of these guys, Robert or John or somebody that's been here a long time, can tell me if I'm wrong on this, but I don't know if there's ever a time where every single thing is just completely out, unless it's some kind of radio blackout. So don't ever let this discourage you from trying to go see what's on the air. Down here under these, I want you to notice it says ESEU. That's in Europe. So these are great. You can look at this and you can see what's going on over in Europe. And you just got to remember, when you see what's going on in Europe, they're 4 or 5 hours ahead of us. And so what's going on there may not be what's going on here, or what's going to go on here 4 hours from now, just because we're going to be where they're at 4 hours from now. The only one that's actually in North America is the 2-meter one right here. So that's the only one that's even in our neighborhood. So I just wanted to bring that to you guys' attention. I see people looking at this a lot and going, oh, look, oh my God. Oh, 4 meters, 6 meters is open. 6 meters is open. No, that's in Europe. And if you look a lot of times on the PSK reporter, you'll see that Europe is open a lot on 6 meters, more than we are, I think. So it's interesting how that works. And then down here, your geomagnetic field, I like to look at that. I mean, that it'll be quiet, unsettled, and it could say storm. It'll say in red letters, storm. There's different things that go in there, and you can look at that as an indicator of something going on. If it says quiet, obviously, then that's an indicator that there's probably not a lot going on. Signal noise, that is an average signal noise amongst a bunch of different stations around the world. Does it mean anything to you? Again, you have to judge that for yourself, because it's not your receiving station that's receiving this stuff. And the muff, same way. That a lot of times is for Boulder, Colorado, I think, is our closest muff station, if you will. And then of course the current solar image, so you can see what's going on. But a lot of times with these things, people don't understand what all that stuff means. So the main thing is look at that solar flux index, and you're wanting 90 or better, means it's going to be amazing. All right, 11-year sunspot cycle. I'm not going to spend a lot of time here because everybody already knows about this. There's actually some indicators now. I read an article the other day. There's a few indicators that 25 is coming on a little faster and a little stronger than they thought, and they're already seeing the right magnetism in some of the sunspots, and they think that maybe 25 is going to be an early starter. So hopefully it is. But anyway, there you go. And high numbers of sunspots and high numbers of solar flux. Of course, that's what gives you the best sunspot. So anyway, CMEs and solar flares, just real quick to go through it one more time. CMEs and solar flares, two different things. Sometimes one in the other, they occur together as part of the same cluster, but flares are giant bursts of X-rays of energy, and they come here at the speed of light, okay? And they travel, in all directions, like an omnidirectional antenna or a light bulb. CMEs are clouds of particulates that are hurled into space. This is stellar matter. It travels a lot slower. This is more damaging, and it comes in at a slower rate. Flares only take 8 minutes to get to Earth. We really don't know ahead of time on a flare. We know one might happen. We know one is, there's a real good chance it's going to happen, but there's no way to know for sure, because even any spacecraft we have that notice it ahead of us still sends the message to us at the speed of light. So there's really no way for us to know. And when I explain this to people, here's what I tell them. The sun could have exploded 5 minutes ago, and the shockwave won't arrive. We'll have 3 more minutes to show before the shockwave gets here. So you have to look at it that way. This is traveling at the speed of light, and it still takes it up to 8 minutes to get here. Sporadic E propagation, something that's going on right now, something that's amazing, something that's really cool. The cause of sporadic E is completely unknown, but the most popular theory relates to wind shear up in the higher altitude. It's an amazing thing. It's kind of weird. Like tropospheric ducting is caused by thermal layers. They're saying sporadic E may be caused by wind shear layers. This is some crazy stuff. Anyway, when this occurs, E reflections are almost mirror-like and can result in spectacular DX and QRP, especially on VHF and UHF. Remember, 6 meters is VHF, and it also works on 10 meters. We've had some 10-meter openings, one yesterday, in fact, between here and Europe, between the eastern seaboard and Europe, mostly the Northeast. Monitoring distant NOAA weather stations is a good way to measure its occurrence. If you're ever wondering, go to NOAA Weather Radio in another part of the state on VHF and look at your S meter and write it down. And then on the next day, go there again and look at that same NOAA Weather Radio station. You can use those like VHF beacons, and you can get you can do your own propagation research based on those NOAA Weather Radio stations, because they put out constant wattage 24 hours a day. And it'll give you an idea of what's going on VHF. So I just wanted to put that out there. Find one that's about 80 miles away, 60, depending on your antenna, and use that with your level meter on your radio to give you an hourly or daily or weekly, whatever, idea of how VHF propagation's running. Man. Oh my Lord, we've had some openings. This was 2 days ago. I think I got 76 contacts this afternoon, this 2 afternoons ago, this day. In the Northern Hemisphere, activity peaks from May through early August, when regular sporadic E propagation enables long distance contacts spanning up to 1,600 miles for a single hop. Multi-hop sporadic E propagation allows intercontinental communication distances of about 6,200 miles, up to 6,200 miles. I've made, I think, 1,500 mile contacts, I think, so far with it. And that's with my 5-element beam. I want you guys to notice in these pictures, and I love following this stuff. You can actually see on these maps, you go to PSK Reporter, and we're going to get into that in a few minutes. You go there and you set it for 6 meters, and you set it for the last 15 minutes, and you tell it to go, and it shows you this map. And I can show you on that map. See how it looks like a big X? The lower part of the map has like an X. There's a cloud right where the X comes together, because people in Texas are talking to people in the Midwest, and people in Florida are talking to the people out in Dakotas. So that tells me that there's a reflective cloud sitting right over Tennessee and North Carolina right there. Or I'm sorry, I'm too far over. Sitting right over whatever, Kentucky, Tennessee right there. And people are using that. Further north, there's a wonderful reflective cloud sitting right over somewhere in the Midwest there, right along the Mississippi on the north part up there. And everybody that's over along, notice everybody in a long line over there on the West Coast, all able to talk to people in the Midwest. It's amazing. When this opens up, you can see right where the reflective cloud must be in order to facilitate all this communication going in all these different ways. This is science, and it's really cool. I'm telling you what, I sit out here till my wife gets pissed. I just can't, I can't get enough of this stuff, man. It's awesome. And then I go inside and I dial in on TeamViewer and I sit there and watch movies with her and work FT8 on TeamViewer in the house. And she's like, why do you keep getting up every 15 minutes? And I'm like, I got to move my azimuth 22 degrees to the left. She didn't want to hear that. But anyway, but yeah, anyway, it's a fun time. I got to tell you guys, if you've never done 6 meters during Magic Band season, my God, you can do it with a piece of extension cord, okay, hooked up to your rig that you've already got. It's amazing. Solar minimum. So we're kind of still in this. I know the Mundo minimum was ever last year. I know we're still kind of in it, but what do we do? What do we do? Well, there's a lot of things you can do, and you guys already know most of this stuff, so I'm not going to spend a lot of time on it. But explore other things, try aurora bouncing and meteor bouncing and all these satellite bouncing, talking to the space station. There's all these other things you can do, VHF, UHF. But the biggest one that I find to be the thing that's great for me is FT8. And the reason is because FT8 allows me to practice with the radio now. It allows me to understand HF now, to understand what band works and how it works, and utilizing Grid Tracker and the PSK reporter and all the information that's available in order to make good decisions on band and azimuth and all these different things. And so I think FT8 is one of the most amazing training tools other than the Baofeng. I think it's one of the most amazing training tools in amateur radio today is FT8. Because when you've made 1,000 contacts on FT8, you know something about high frequency radio. I'm sorry, because you have to understand a lot. You have to figure out a lot. And if you're making 10,000 mile, 8,000 mile contacts over to New Zealand and Australia and things like that, you're doing something right, and it's great. And when you improve your skill and you improve your system, and you improve everything during this time when it's slow using FT8, then when we get back to the phone during the solar flare season, I plan to be back on I want to be on the phone. I want to be making phone contacts. So anyway, there's that. FT8, if you're not on FT8, if you've ever taken any advice of anything I've ever said, check it out. If you need help, let me know. I can get some radios on FT8 with a $9 sound card and some soldering and wire. You got to get on anyway. There's some neat services out there. Just want to mention real quick. Vocap. I don't know if has anybody used Vocap? Anybody? I sound like that teacher. Anybody? 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 I haven't used this either. I came across this and it looks really, really cool. So I'm hoping it's all still working and everything. It looks a little complicated, so I didn't dive into it because I had to keep going. You know, when I'm setting up for one of these, it's kind of like the train. It's got to keep going down the tracks. But this looked interesting. So if you've never seen this, you might want to check it out. It's like a program. Well, here, the next screen kind of shows you what it looks like. This is like the screen, and it kind of shows you a little bit of what it does. Pleading ignorance on this. I was kind of hoping somebody out there has used this one, but I'm putting it out there so you can see it and write it down and check it out. If you put in VOACAP, I'm sure it'll come right up. But notice that what I thought was really cool about this, it shows you what bands work in what directions. So like if you're going to be on azimuth 20, it'll tell me, okay, at a certain azimuth or whatever, that this band's not going to really work that well or whatever. And I'm like, that's pretty cool. And there was another, I think this tool here. Oh, I'm not even sure now. This might be the time tool here. Yeah, this is the times here. This is 24 hours a day. And what this is a probability of what times each band would be the best to get on. See, like this is telling you that 21 and 2200 Zulu would be a really good time to get on 20 for us. And I do believe that because that's right about 5 o'clock at night, which is a good time to get on 20. So that's what that's supposed to show you. You can also plot the probability of making contacts and stuff. But like I said, I have not used this thing yet. So I'm pleading total ignorance. The one I have used is called PSK Reporter. Going to go kind of fast here, but if you've never used PSK Reporter, this is probably this and DX Maps. I know some people prefer DX Maps and some people prefer PSK Reporter. That's almost like the Apple and Windows argument. Okay, if you like one or you like the other, or what is it, John? There's the map tracker program that I use, and then there's that other one that you and a lot of other people use. It's a personal preference thing. If you like one or you like the other, stick with it because they're both providing great information. It's the same thing with this, the PSK Reporter, and I'm going to get to the DX Reporter next. The PSK Reporter, what's great about that is it's so quick and easy to use, and you can set it up right on your WSJTX so that you can provide data. It's always important, I think, that if you're going to use data, that you should provide data. It's kind of that human thing. Let's just take a real quick look at PSK Reporter. Up at the top, you choose all bands, or you can select the specific band you want. And they've got all the different bands in there, even the ones that we don't use here, like 4 meters. They're all in there, and you can select different the band that you would like to look at. I like to keep one screen on 6 meters, one screen on 10 meters when I'm doing Magic Band. Show B, you're going to leave this on signals sent and received, and this explains that if you set that for a specific station coming up, you can tell it whether you want only things that station received or only things that station was trying to transmit to. That's basically what that is. Who, that's where you would put in the call sign. If you want, you can put in call sign, and you can put in your call sign. I showed this to a couple of people this week, and both of them were just amazed at what this thing will do. Because you can actually put in, and I don't know if let me see if I can go. I've got a few examples here. You can actually, this is 20 meters right now. This is live. There's 20-meter opening right now between the Northeast and Europe. And there's also another one between the Caribbean and in America there. So, or the United States. So, and it looks like South America is able to get into the Northeast as well. So we've definitely got some magic clouds out here somewhere. And then if you want to see, I'm not sure what I've got all pulled up here. This is everything. You can pull this up. This shows you everything. And you can use all the colors are up top here. This is absolutely an amazing tool that I use. Now, if you want to look at what KO4 EFS, this is just what my station has either spoke to or heard from, not necessarily talking to me, but stations that my station was actually able to verify a call sign and a grid for. This is all the stations that my station was able to actually listen to or talk to. So I think this is an amazing tool because let me tell you what I do. Let's say I'm wondering what's going on with 2 meters. Is there anybody on FTA 2 meters on sideband? So you leave it on for 24 hours on another radio over here on an omnidirectional antenna. You stick it on here, you turn on the PSK Reporter, you turn off the screen, you forget about it. You come back 24 hours later, you go to this, and you can pull up your PSK data from your machine for the last 24 hours and see if it ever did hear from any of those stations out there. So that's really a cool thing. So there's just a lot of different things that you can do with this. It's just absolutely an amazing thing is the PSK Reporter. Now, real quick, a couple of things you want to do when you get in there is you want to go to your settings screen, and you get to this screen by clicking display options up here. Okay. And real quick, your mode and your hours, that's all self-explanatory. I don't need to explain that to you guys. Display options, you click that. When you click that, you end up with this screen. One of the things you might want to do, I click these just to keep the clutter down. And I like the connecting lines. So I click show connecting lines. Other than that, I pretty much leave it the way it is. You can change this here. Look, you can change this here. One map has like a globe. The other map is the one that's stretched out like this. So you can have it however you want it. There's a lot of really cool things you can do here. One thing you want to change is distance to miles. It comes in kilograms or whatever. And put that connecting lines there. All right. Those are the main things. On your WSJTX, be kind and be a data provider, please. It relies on all of us to do this. You just go to your reporting tab, click that box, and then click OK. That's all you have to do. But if you don't do that, you're not helping us out. Okay? That's all there is to it. So if you're on FT8, please take a quick look at this for me. Go to your reporting tab, turn on the PSK reporter. I don't think Al-Qaeda is going to use it to find us or anything. Turn on your PSK reporter, click OK, and you're all set to go. All right, DX Maps, another really, really good program that I'm not going to take time to show you. It actually probably does even more than PSK Reporter and is an amazing resource. And I love the maps, the way this thing produces the maps. It's got some amazing functions up here, but you're going to learn it yourself. I don't have time to teach you tonight. But definitely, if you like PSK Reporter, go check out DX Maps and vice versa. How much does the antenna matter? You know, it's not just what kind of antenna you're using, but there's one more thing I want to talk real quick about, and that's takeoff angle. This is something I didn't realize till later on a little bit. Your NVIS, your near vertical instant skywave. I'm so surprised I'm able to come up with all this. I love that because the takeoff angle is really high and you get closer stations. You can do DXing and stuff with it. Really cool. But their takeoff angle is important. If you're using an inverted V, changing the inversion of your V can actually affect your takeoff angle some. So there's different things you can do for that. And so I suggest that if you've looked at everything else and you want to try something different, look up how to take whatever antenna you have and see if there's any way to adjust the takeoff angle a little bit. Go up or down on the takeoff angle. The gray line. This is something I find really cool. You can actually talk across the gray line. Like you're in, let's say, the nighttime, but yet say the place you're talking to is in the daytime. So you're actually talking from one type of atmosphere into another. And you're thinking, well, that makes it worse. No, a lot of times it actually makes it better. You can actually go DX further is if you're crossing a gray line. The way it works basically is all the layers don't change at the same time. The D layer disappears, allowing HF signals to better get to other layers. So right before dark, as the D layer is starting to disappear, you're actually going to get some of the nighttime benefits, even though it's still kind of daytime outside. So that's one reason why working that helps. E dissipates a little later, and then the F1 and F2 remain. And then eventually the F layers will combine, because at night you just basically have one big F layer up there at night. So while all these transitions are happening, you can take advantage of using that opportunity to bounce signals off of things. And it changes the actual gray line, changes the propagation characteristics from your station to the one you're calling, if one is in day and one is in night. That's really cool. I say that's really cool after every slide. I apologize for that. Okay, VHF and UHF propagation. This is really cool. This doesn't have a whole lot. It all has to do with the sun, but this doesn't directly have as much to do with the sun as it does basically a thermal layer in the lower atmosphere. This happens much lower in the atmosphere. I noticed this a lot with our FM radio station. If I start getting calls and people say, all I hear is Spanish music, did the federal government finally shut you guys down? I said, no, they didn't. It's called tropospheric ducting. And what it does is it actually creates a trough in the upper atmosphere, and the radio waves are actually ducted down, and it creates a situation. Usually by then they hang up. But anyway, it is really a cool phenomenon, and it affects our stuff too. It affects 6 meter, it affects VHF, and it can affect UHF when it's running really bad. What basically happens is just kind of what I just said. There's a thermal layer that sets up in the atmosphere, and it takes FM signals, mostly FM. VHF is most susceptible to it, between 50 and 150 megahertz. And it basically creates like a tunnel through the atmosphere at a low level, and it drops that radio signal back down on the other side. And so what ends up happening is the radio station that sits out on St. Petersburg, that's propagating over nothing but water, thank you very much, it actually comes crashing down on top of our signal that's trying to fight up over Fort Myers coming from a stereo. Okay. And so what ends up happening is it pushes back our signal, and people wake up in the morning, they hear Spanish music, their alarm goes off, they want to hear their news and talk, and they end up hearing Spanish music, and they immediately think that it's the end of the world. And it's not. It's tropospheric ducting. It's an amazing phenomenon when it happens. And we find out when this happens that people down in Alamorada are listening to our radio station in a stereo, because when it happens to us, it ends up pushing the Key West station further down. So it ends up moving everything down. So that's tropospheric ducting. So if you're ever sitting there one day on the 685 and you hear the Bradenton repeater loud and clear, I did that one morning. I was sitting here listening to them guys checking in up there, and it was loud and clear. So I went and programmed in that PL and checked in on their net. The ducting was working great, and it normally works in both directions. To find out about tropospheric ducting in real time, you can go to the Southwest Florida TechNet website. Under the Propagation tab, click tropospheric ducting. Detrimental sunspot activity. Sunspot activity can be detrimental to radios, satellites, GPS, our astronauts, and even our power grid if a strong enough EMP pulse was kicked off. See, we've been talking about all the cool stuff up till now, but it gets a little darker going forward. These basically this energy that's basically unleashed at us from the sun, it causes these beautiful auroras. That's great. But it also creates all those kinds of solar flares as well. And we're going to be talking about all that in just a minute. But before we do, I want to get into some tips and tricks. This is some real neat stuff I picked up along the way when I was doing my research. If you're in a QSO, when a major flare causes an HF blackout, it seldom lasts more than an hour. Like I said, that one I witnessed lasted about 22 minutes total was the total blackout time. If you're working a contest, this could be useful. Take a break. The X-rays do provide extra ionization in the ENF layers, and they do improve reflectivity and a higher muff. So exploit the benefits of a solar flare. Either they might increase your contesting, and that's great. They might shut you down for a little while. Take a break. Good DX contacts are possible immediately following a solar flare until sundown, due to the improved reflectivity and better signal to noise ratio for QRP signals, and the higher muff opening in higher bands, especially during the solar minimum. So basically what that means is, let's say it's 4 in the afternoon and a big solar flare happens on the sun. Between 4 and 7 o'clock, between the time things open back up and 7 o'clock when the sun goes down, you could see unusually high propagation on day bands, like 20 meters, because of the way this sets up, and the noise floor is going to be really low. Most important thing to remember about a solar flare is this. The HF effects are generally only for the duration of the flare event, 20 to 60 minutes, and they seldom affect frequencies below 10 megahertz. So basically 40 and 80 aren't really that much affected by solar flares. They're affected by other things, but not solar flares. Use the current K index from the WWV or the internet to determine the current geomagnetic field conditions. The A index is actually yesterday's geomagnetic field condition. And that's, like I said, that's if you're getting more into the advanced stuff. QRP propagation. Often our magnetic field gets very quiet following a strong geomagnetic storm for 12 to 24 hours. This is an excellent time to work 40 to 160 meters due to the noise level being very low. So once again, following a major solar storm, we're going to see unusually low noise floors. And it's a good time to get on. The solar flux indicating the level of ionization. That's that farthest left number up there that I told you to watch out for. We're looking for values 90 and above. The solar flux indicating the level of ionization affects HF propagation above 10 megahertz. The solar flux does not affect 40 megahertz and below, since the MUF seldom drops below 10 megahertz. This is why the lower bands are always open. And yeah, you'll find it doesn't, again, it doesn't have as much effect. 20 is highly susceptible to radio blackout. Okay. 30 meters is the ham band caught between two worlds. It can be affected by both solar flux and the K index. On the other hand, it is more often not bothered by either one. It's a good band through the solar cycle. So again, if one's screwy, the other's screwy, the one in the middle might be the magic one. You know, you never know. Every solar flare and the resulting storm is different. No two are alike, and they cannot be accurately predicted. We can have one that is almost a near miss, and we know it's coming right at us, but until it actually arrives, we don't know how much of that energy our shield's going to have to endure. Never let reports of flares or geomagnetic storms or the lack of scare you from getting on the air or checking it out. I have gone on in almost every imaginable condition during this quiet, and I've always found some band that I can find somebody on. So don't ever look at a solar flux index or look at the band openings in Europe or look at something like that and decide, you know what, not going out to the shack tonight. I'm going to bake cookies instead. Don't do that. I'm telling you, go to the shack, because you never know what's going to be on the bands. It doesn't matter what that stupid thing says. The Carrington event. I don't know if you guys have heard the Carrington event, but it was a big event. It happened on September 1st and 2nd in 1859. It was during solar cycle 10. I was pretty young, so I don't remember it that much, but apparently it was pretty bad. During the Carrington event, basically what happened was the Earth was almost directly in line with a coronal mass ejection, basically. And it was observed by an astronomer named Carrington, and that's where we get the name. And basically what happened was, all of a sudden, he sees this thing, and then later on, a bunch of stuff starts happening. But this energy comes in, and as it comes in and it wraps around our shield, and it gives it quite a bit of hell. Anyway, I'm not going to go through this whole thing, but basically what we got here is the perfect superstorm in 1859, the Carrington event. That actually is a drawing that was done based on the observations that were made through solar telescopes at the time. Obviously, there's no photography or anything else other than just the written word that people put down, and this drawing that was made by Carrington and some others. On the morning of September 1st, amateur astronomer Richard Carrington ascended into the private observatory attached to his county estate outside of London. After cranking open the dome's shutter to reveal the clear blue sky, he pointed his brass telescope towards the sun and began to sketch a cluster of enormous dark spots that freckled its surface. Suddenly, Carrington spotted what he described was two patches of intensely bright white light erupting from the sunspots. 5 minutes later, fireballs vanished, but within hours, their impact would start to be felt across the globe. That night, after the event happened, when all this energy began to arrive here at the planet, Telegraph communications around the world began to fail. There was reports of sparks showering from telegraph machines, shocking operators and setting papers ablaze. They actually unplugged their batteries, and they were still able to send messages vast distances just from the electricity that was being collected by the lines. They could unplug their batteries and transmit at 30 to 90-second intervals. Some thought it was the end of the world was at hand. A massive solar flare with the energy of 10 billion atomic bombs spewed electrified gas and subatomic particles towards Earth. The resulting geomagnetic storm, dubbed the Carrington event, was the largest on record to have struck the planet. Americans in the South were particularly startled by the northern lights, which migrated so close to the equator that they were seen in Cuba and Jamaica. Can you imagine waking up in Southwest Florida to green and red auroras dancing in the sky? I would hope that my antennas were unplugged. In Abbeville, South Carolina, Masons awoke and began to lay bricks. They thought it was time to get up. The sky was so bright, they thought it was morning. In cities across America, people stood in the streets and gazed up into the heavens at the pyrotechnics. In Boston, some even caught up on their reading, taking advantage of the celestial fire to purse the local newspaper. Newspapers from France to Australia featured glowing descriptions of brilliant auroras that had turned the night into day. And they did some ice core samples. This was the biggest event like this in 500 years. This is the big one. What would happen if this happened today? I mean, think about it on this scale. I mean, that's some amazing stuff. Well, okay, we'll start here. All of our stuff right now is hardened, okay? You know what hardened means? It means it takes more abuse before it goes down. That's basically all it means. Satellites. Our satellites can go down temporarily or permanently. If it affects their flight systems, they'll eventually all just burn up in the atmosphere and come back that way. It could just burn them out and they'll just float around for a while before they slowly come back. If all of them go out, we know where we're at. I don't need to tell you. Power grid. The big thing during a solar storm like this is the power companies are literally going to have to dial it back to zero. They're going to have to bring the power down to nothing, because the power that our power lines all of our power lines are going to be like a collector, and they're going to collect all of this electromagnetic energy, and they're going to try it, and they're going to try to move it across the electric grid like electricity. And it's going to overload everything, the equipment that moves it, the equipment that's plugged into it. So power grid, definitely not just the grid, but anything plugged into the grid is at high risk. Connected equipment, anything connected. Radios, again, your antenna is an electromagnetic collector, and it's up there collecting. So you can do the math. If the storm's big enough, it would affect your radio and damage it. Computer chips. There's fine hairs inside of every one of these little chips. There's little teeny microscopic hairs in there. And if those hairs are exposed to enough of this electromagnetic pulse that comes in, they fuse. And once that happens, that piece of equipment is 100% useless going forward. It will never be revived. And the data that's on it is lost. Communication systems, connected systems, like cell phone systems are incredibly vulnerable to stuff like this. Of course, some of the systems we use are more hardened, a lot, because we're there to unplug them and protect them. Part of our hardening is not that we spent millions of dollars like the government to harden something. Part of it, when we harden something, is I know when to unplug the damn thing so it's not going to get blown up. If you have spare equipment, keep it disconnected. Now, I'm talking about, this could be for any reason, okay? One thing that another country might do as warfare is touch off an electromagnetic pulse over us, and that would have a very similar effect to a solar storm. So when I'm talking about this, what I'm about to talk about applies to both energy from the sun and also a man-made electromagnetic pulse device. Either one would apply, okay? If you think either one of these may be possible, if there's a huge solar flare, a sunspot rotating around, and it's the nastiest one in 50 years, and just unplug everything. Unplug everything. Make sure that the shell of your shack is grounded, and just unplug everything. Have nothing plugged into antennas or power or ground. When your radio is completely unplugged, unplug the ground from it too. Unplug everything from it and isolate it inside a metal box or a metal garbage can. Keep equipment turned off. Keep antenna power lines disconnected. Connect only the external conductors necessary for the current mode of operation. So in other words, if we're thinking there might be a bad solar storm and it could happen, this is something that may not happen for years, guys, but it's something that potentially could happen. If we think something like this may happen, it's probably a good idea. Take your primary 2 or 3 radios and sit them down inside a metal garbage can and put it over to the side and hook up your backup equipment and utilize your backup equipment to get through it. You want to keep, you want to save something. Okay. Tie all fixed equipment to a single point earth ground to prevent closed loops. This is if you're leaving it set up. Keep everything grounded if you're leaving it set up. Obtain schematic diagrams of your equipment, tools, components, repair of equipment. This is where a lot of people there's always that argument. Well, I've got all my manuals for all my radios and all my programming guides and all my frequency lists and all my ARRL disaster guide and my Aries guide, and everything is all on this thumb drive. I don't know, guys. Is that enough? You're going to have to plug that in somewhere to look at it. So there's something to be said. I don't know if I've got it here somewhere here. I've actually got a 3-ring binder that I've got the Aries guide in, and I've got all of our frequency lists and all that. And I'm actually starting a paper one. I've decided to go old school on some of it just in case it gets really bad. So you might want to have really critical things on paper. Have spare parts on hand, sensitive components, radio equipment, antenna systems. Never hurts to have spare stuff. Know how to repair and replace sensitive components on your own radios, and use non-metallic guidelines and antenna structural parts whenever possible. Obtain emergency power source. Of course, it's always best to do that. Anytime you're connected to commercial power, that is going to be your biggest threat for electromagnetic pulses coming into your shack, more than even your own antennas. Equipment power cords should be disconnected when gear is idle. Again, if you're not using it during a threat. I leave all my stuff on all time. But if there's a threat, I'm going to protect some of it. I got to keep some of it back. Install, have a spare antenna and transmission lines. Believe it or not, a bad enough solar storm is going to damage your coax. So that's something to keep in mind. If coax is not connected, it will not be damaged. So if you've got backup radios connected and we get a bad pulse, it could literally affect your coax line. It not only destroy your radio, but your antenna and your coax line could also be at some kind of threat as well. And here's something that a couple of you guys are really going to like, Dave, and a few of you guys. Keep some of that tube equipment around, man. Just keep some of that stuff around that doesn't need computer chips to talk. And don't rely on anything that, have a way to do everything without a microprocessor, basically. The Faraday cage, I don't need to tell you guys about these. I'm just going to gloss this, but Faraday cages are important. You can make a Faraday cage out of anything. They sell those little metal bags now that you can put stuff down in. They're big enough to put like a mobile radio down in. You can put them in like a Ziploc, aluminum Ziploc Faraday bag, I think they call it. Metal garbage cans. I keep coming back to that. I'm going to buy me a metal garbage can, and I'm going to put it in the shack, and it's going to be part of my shack right here. And any radio that I don't have hooked up for use, I'm just going to sit down in that garbage can and put the lid back on it. Why not, right? If I'm not using it, why let it sit on the counter? I'm going to put it down in the garbage can where it's safe. As long as my wife doesn't come in and throw that garbage can out. Here's some other things you might want to consider saving. Calculators. Yeah. Anything with electronic ignition, it could be damaged. Cars, or for instance, that's something people take for granted. During a huge EMP, your car will not start. Cars made before the 80s will. So that's where, it all depends on how electronic your car was. All right, let's go through some web resources. I just got a couple more I want to tell you guys about. We've got spaceweather.com. This is my favorite website. Absolute favorite website. I go here every morning and I check this before I check my news sources or anything else. I love spaceweather.com. There's always what's going on right now is the first thing you see, and the second thing is an article about something else that's going on right now. So those are great. You're going to see things on here about your meteor showers, about any CMEs, any solar storms, anything. It's all going to be reported on here. You're going to get advanced notice of things on here. It's really cool. So spaceweather.com would be my number one go-to. Another one is, of course, the NOAA site. It has the NOAA scales, which is their new semi-new way of telling you guys about solar storms and what their predictions are for solar storms. So if you've not visited that site, it's swpc.noaa.gov. And it's actually a wealth of resources. It's actually pretty good for a government website. You go there, get information. I mean, that's a good start for a government website. And then, of course, the Southwest Florida TechNet. You can get all your information right there. And I've got 3 tabs at the top to help you guys go to all the different things you might need to find on there. The weather tab, I've got all the different weather maps. Propagation, those are all the different propagation tools, including what we talked about earlier, the tropospheric ducting. There's all kinds of different tools. There's that VOACAP that we talked about. There's all kinds of different tools there under propagation. And then under resources, you will find an amazing amount of resources there. So all that's available for you 24 hours a day, 7 days a week, 365 and a third days. And that's pretty much that. So, all right, guys. And that's what I have basically for the solar presentation tonight. I decided I wanted to try to keep it under an hour and a half, and I did. I did not want to go too far. I see a few people are asleep, but most everybody's still awake. So that's cool. I must have did something right. I will tell you guys that, like I said, this is absolutely my favorite topic. I absolutely love space weather and all the related stuff. All right. Let's see here. All right. I'm going to open it up at this time to anybody that has any questions or discussions about anything ham radio or anything about the solar, the sun, our space weather environment, and how it affects amateur radio.
I don't know. I think that Carrington event was really cool. And if one happened today, I would be both fascinated and worried, but probably more fascinated and excited.
I love that echo effect. It's like, I like that. Everything's twice. It's
Wait,
cool,
what?
cool. Yeah. Everything you say twice. I can almost do it. Almost do it as good as you. I don't know what it's.
Okay, how is this? Does that fix it?
No, it's like there's 2 of you.
Man.
Which is okay. If it was some of these other guys, I wouldn't want 2, but 2 of you is okay, I guess. All right. Let's see here. Anybody else have any questions, comments? Anything? Come on, guys.
Yeah, this is Paul.
Hey, Paul.
Hey, well, thanks for the very nice presentation. Anyway, I may have been 10 years or so. I met a spectroscopist, very distinguished person, and he asked me a question. Do you know why the sky is blue? And I said, yeah, not really. So he goes into saying that, our atmosphere consists of 78% nitrogen and 21% oxygen. And so what's happening, and this is the sun issue here, the cosmic rays coming from the sun are basically ionizing the atoms of nitrogen and oxygen. When they hit these atoms of nitrogen and oxygen, the electrons get into excited state, and then when they come down, they emit light. Now, I said, well, how do you prove this? And he said, well, it's very simple. And he said, you take basically a tube where you put the electrodes at one end, the other end, you evacuate it, you put some nitrogen there, and then you hit it with some, high potential, or you can use a taser. And what's happening is this tube will start generating, if there's a nitrogen, blue light. And if you have oxygen, you get something like an amber light. You know, we have a neon tubes that generate, if I remember,
Oh, yeah.
the red light. So every atom, when it hits with electrons, I mean, I'm talking about the gaseous atoms. When it's hit with high energy electron or high energy particles from the sun, basically knocks out the electrons in the gaseous molecule, nitrogen, oxygen. It brings in an excited state, and it's very well known as the electrons are coming down into the original orbital, they generate light. Now, the thing is, another proof is that when there's a night, there shouldn't be any ionization, right? Because essentially sun is on the other side of the globe, right? But in order to come up with my question for you, this is probably very difficult. We understand why the sky is blue, I believe, but I'm not sure about this aurora borealis green light.
Ian, you're muted.
Ion, are you there?
Yeah, I'm here. I'm sorry. I muted because I'm having some issues here, and I was trying to fix that.
Did you hear what I was saying?
I heard everything you said. Yes, absolutely. Okay. And as a matter of fact, the colors that are associated with the aurora are. Oh, hold on just a second. There we go. The colors that are related to an aurora are actually very different. They're not always green. Auroras can be any color under the sun. And they say they really don't understand exactly what makes each color, but it all has to do with that energy as it's coming in and it's being excited, like you said. So yeah, I think that's a very interesting phenomenon. I know that blue color in the sky has a lot to do with the reflected light with that phenomenon you were talking about. Some very neat stuff. Yeah, the aurora is something I would love to see. Has anybody actually been able to see the aurora? Somebody? Anybody? Yeah, I think Lynn said yes, and Bruce. So there's a few people out there. I'll tell you, it's a bucket list thing for me. It really is. And I really want to go see the aurora. I want to go see it really bad. And I don't know if I'll ever actually get to see it. I showed the guys last week, and so forgive me for forgive me if I'm being repetitive for the four of you that hung out late last time, but there is so many cool ways to see auroras now. Do you guys realize how many cool ways there is to see auroras now? Look at all the cool ways there are to see auroras now. Oh, man. I want to take the wife to any one of these. You just pick one. That one looks like some kind of spaceship. I think this one right here will be nice. I think that would be nice for the wife and I. What do you think?
I don't know. Ian, does she like cold?
Well, see, that's the cool thing. It's not really cold inside there. I guess you got to get there, I guess.
Hey, Ian.
Yeah.
This is Jim, WDAJEL. Can you hear me?
Yeah, I hear you.
Okay. I was up in Traverse City in the 90s, and they had predicted aurora that evening. You know, Traverse City's up around 45 degrees north latitude, so it's in the aurora area. And I was very interested in seeing it. So I drove east from Traverse City so I could get out of the lights of the city.
Mm-hmm.
And I drove miles and miles and miles, and every house had a mercury vapor light. I did not see the aurora. I was very disappointed.
That sucks.
Yep.
You know, you don't realize how much light pollution that there actually is until you really need it to be rid of it. But if you guys have never done it, there are absolutely some amazing videos online of the aurora. There's actually a few that are like relaxation videos that are really cool. But let's see if I can get one of these to. Well, that don't look good. I don't know what's up with that. Anyway, some of these are amazing. There's like this one's like 6 hours long. This one I'm looking at here. But there's just some amazing ones. If you guys have never actually just sat and watched the aurora, it's one of the most heavenly things that there ever is. I for some reason cannot get enough of it. Let me see here. I'm trying to get this up to where I can put it up on the screen. Does anybody else have any other aurora pictures or aurora stories?
When I was a
Aurora
boy, we had
Borealis at this time of year, at this time of day, located entirely within your kitchen.
Yeah.
May I see it?
Yeah, I absolutely love it. And then when you understand the phenomenon and what's causing it, I think it's really cool. And you'll see here, they're all different colors. They're unlike the blue sky, these can be literally any color at all. And again, most of these are sped up. They move more like clouds. Like, you know, they're moving, but they're just below your perceptual range. So it's kind of, you know, if you close your eyes and look back up, you'll notice it's moved a little bit. I think I heard somebody tell me one time they were a little. Go ahead.
No, yeah, Ian. Those look like they are speeded up a little bit, but
Yeah, they are.
you definitely see the movement. You see, it's like sheets of color coming down, and it is very spectacular. I've seen it a number of times. When I was a youngster, we had a cottage up in Port Huron, Michigan, which is not that far north, but you know, if there's enough activity, you're always looking towards the north, and we were looking up over the extent of, you know, we had a good low horizon we could see it on. And actually what you're showing there is not that far from the reality of it. And
really, so okay, it is. So the movement is it. Yeah, I was told it's more like fast moving clouds, and that most videos we see are actually sped up. But yeah, I'm glad to hear that you can actually see it moving. That's cool.
Oh, there's plenty of motion. There's plenty of motion, and you see it's predominantly green in a lot of these pictures. And I don't remember the physics, but it is known. You know, each one of those colors is due to the energy of the electrons or the protons that are coming down and exciting the atoms in the atmosphere. And I think it depends on the energy of the electron and what it is, but it is known which, you know, what phenomena produces each one of the colors, and some of them, they're a lot more, you know, some of them are a lot more common than others. It takes a lot higher energy for some of the colors than others, and I think red is relatively rare, but they do change color. As you're watching, you'll see different colors. And one of the things that I recall from learning about this is that something interesting to keep in mind is that the mass of the quantity of particles, these are small subatomic particles that are streaming off of the sun, but the total mass, if you put them all together and basically weigh them, if you will, that it can be as much as a mountain range. In other words, as much
Wow.
as so it's an awful lot of material that's coming off of the sun. And I think the thing that keeps us out of trouble more than anything else is if you take the perspective of the sun, if somehow you could put on your thermal suit and sit on the surface of the sun and look out into space and see what the sun, what you could see from the sun looking our way, that the Earth would be just a tiny little speck out there. And so when you look at it from that perspective, you can throw an awful lot of mass in one direction, but it's kind of everything has to line up just right for a large proportion of it to hit the Earth.
Right.
Usually in the CMEs, you have 360 degrees, in 3 dimensions all the way around the sun. And the material can go in any one of those directions. And we are just one little speck up there. So for a substantial amount to run into the Earth, it's a relatively unusual event. And luckily, that's lucky for us. So we don't get clobbered.
Yeah, I heard it explained one time that the sun is like a shotgun and Earth is a very small moving object that's hard to hit.
Right.
And,
Wait,
and not only that, but when it comes to the geomagnetic disturbance, that bunch of junk, sun actually carries a magnetic field orientation with it.
Yeah.
And when that orientation has an angle with respect to the orientation of our magnetic field, which of course is north and south, when it's lined up in almost any direction other than south to north, it is deflected by our magnetic field and has minimal effect. If it happens to be lined up parallel to our magnetic field, then it's absorbed by the magnetic field, and the consequences on the planet are much, much worse. So not only are we a little speck out here and hard to hit unless the sun would be aiming right at us, but the orientation of the magnetic field matters too. So every degree that it's off of lining up with our magnetic field gives us more protection.
All right. And I also, one last thing, what happened with the Carrington event and what also has happened over time is we'll see that there'll be several of these ejections that will happen. And each of these waves of energy will be moving at a different rate of speed. And if you have a large one that's moving slow, and right as it arrives, another large one that's behind it that's moving faster arrives at the same time, you end up getting it almost like triples the effect because you have 2 waves arriving at the same time. It's kind of like when you're on the double Ferris wheel and you're going over the top right as you're going over the top. It gives you the double effect. And it's kind of the same thing with that, I think. So
absolutely. Can I make one more comment?
Absolutely, as many as you want.
Well, let me compliment you on the quality of your slides and presentation. I've been in the position for many years of having to make presentations on these subjects, and it's always a problem to do something that's visually pleasing and fun to look at with respect to this subject. And you have done an absolutely outstanding job. I don't know where
I appreciate that.
I don't know where you got all these visuals and the slides and and all the things that you got, but it was outstanding.
Well, I actually, I created the material myself. I did not rip this off from somebody else's PowerPoint. I just love this stuff, and I just really wanted to do it. And I've been wanting to do this for a while. So, and I started this about a month ago. So it's kind of been a labor of love. But
I'm going to second Bruce's comments. Ian, you did a great job tonight. I think it was awesome.
Well, I hope so. I appreciate it. I really do. I try very hard to put something out there that helps people out, and maybe people get something from it. And it'll be on the YouTube, so people can go later and watch this if it's good. You know.
So as an aside, I just Googled see the aurora online, see if there's any webcams. There's actually a website called seetheaurora.com/webcams, and there's webcams in Norway and Canada. Maybe you could see it that way.
Yeah, I've actually looked at some of those. It's kind of a fleeting thing, unfortunately. Yeah, nothing's going to be like seeing the real thing. I don't think, you know. I swear, I don't know how to get this thing to stop. Oh, there we go. I think I just did it. No, that didn't do it either. Remove all spotlights. Yes. Okay, there we go. I think that's right now. No, that's I don't know what's going on. All right, I think that's correct now. All right. All right, guys. That's basically what I have on that. The only other thing I want to talk about it. Does anybody have anything else on the solar cycle stuff? The anything we've discussed so far tonight?
I have
Anything else? Last
something.
call.
I have something. Can
Yeah,
you hear
go
me
ahead.
now? Am I still got
Yeah,
the echoey thing?
Nope, I got just one Joseph this time.
Okay, good. If there were a storm headed right for us from the sun, is there anything we can do to know early on that it's coming? You know, I know we may only have 8 minutes, but is there any way to do it to know it's coming without relying on an emergency alert on your phone or the government to tell you? Is there any way, any instrumentation? Is there any way for us to have an early warning system, even if it's just a minute or two?
Well, remember, there's two
Yes,
things.
there is.
Yeah, go ahead, Bruce.
Yes, there is. The Space Weather Prediction Center, I believe it's operated by NOAA. You can sign up and get bulletins from them, and I have not done it. I can't give you the precise specifics on how to do that, but if you Google up their prediction center and look around in there, you can find a way where you can sign up to get bulletins and warnings for geomagnetic storm events.
Okay, I'll check that out.
Yeah, and here it's one of those things. You know, if it's a flare, you may not know it's just going to happen, and there's going to be a radio blackout. But the one that's really damaging does take a while to get here, so we do get some warning. If it's a CME or whatever, we will get some warning on that. That's the good thing. And
Good, yeah.
Here's that. Here's that website. This is that's the Space Weather Prediction Center, and this is basically their scale that they use, and these will start turning colors and doing things as things start to happen. Let's see.
Yeah, they actually have some sort of subscription service, and I'm not sure exactly how you can get that. Yeah, subscribe, maybe that's it, where they will actually send you bulletins. And it depends, and I think you can sign up for what kind of alert you want. Like, you know, for amateur radio, we might be interested in flares and so on and so forth. But if you're an electric utility, you're really just interested in the geomagnetic storms.
Right.
and they're working continuously to upgrade and improve their predictions, for their impact on the electric grid.
I see they got a really cool aurora forecast map here on the NOAA website.
Yeah, very cool. Yeah, I've got, believe I've got, yeah, on my website here, you can go to, I got an Aurora tool there too.
Oh, nice. The Tech Group or TechNet?
Both,
Okay.
either one. But this shows you, see, you can see the little green right there. This will actually show you the Aurora oval. So will this.
Yeah, that's what I just looked at. Hey, you got it. Nice. Okay, this is better.
Yeah. And these are all dynamically updating, supposedly. If they're not, let me know. I got to fix them. But yeah, I got all that stuff right there on the under propagation. And you guys, if you've never looked it up, you can actually bounce radio waves off of auroras.
Oh, I know. That's the coolest thing.
Yeah, I thought that was pretty cool. But you can get to all that stuff right here.
Wow. Yeah, this is definitely going on my list of things I want to do one day is go see the aurora. I looked at videos of it, even like the 4K, high resolution videos, even on my nice monitor here. It still just looks blurry.
Yeah.
I guess because it's trying to film at night, and that doesn't really work very well on cameras.
Well, and a lot of times they're speeding it up or whatever. And
yeah.
I think sometimes they're doing some colorizing and things like that too. And it just kind of makes it grainy.
Yeah. I want to see the real thing.
Yeah, me too. Me too.
And then try and bounce a radio off it.
All right. And you guys, one other thing I want to mention, we'll move on to the next topic here. We've been using a UHF repeater here in North Fort Myers, and we've been having great luck with it. It's the 444-775 repeater. We've been trying to, Joseph and I, and there's been several of us, Rick, and I don't know, there's 4 or 5 of us that are trying to monitor it all the time. So if you guys want to try to give us a call, I'll be monitoring it through the weekend. Don't forget, we got the ECOMS exercise tomorrow at 11 a.m. For those in Lee County. But also, anytime over the weekend, if you want to try to give us a call on that repeater, we're kind of using that as just our little talk around channel here for our little projects we're working on. But I hooked WinLink up to it for like 3 days, and it worked great. And so I think we're going to be playing around with that some more. WinLink is not WinLink, Echolink. I said it again. I did it again. Echolink. I hooked Echolink up to it, and it worked really well. We were actually talking back and forth, one on the repeater, one on Echolink, and it was actually working really well. So we're going to be able to, at will, attach Echolink to a repeater. And now I'm going to be working on, would we be able to connect 2 repeaters together using Echolink at a third remote site? And so that's going to be the next thing we're testing. As soon as I get a second Echolink system set up, I'm going to have it in a separate location. But what I want to do is I'm going to beam one tower with one system and the other tower with the other system and hook them both into the same room in WinLink. And they're doing this in Charlotte County for the CC Flares meetings and stuff, and it's working. So I want to try to work on it down here. I want to give us the ability to immediately connect a couple of repeaters together using WinLink, and then connect those to the internet, of course. So we're going to be playing around with that. So if you guys are out and about and you want to give us a shout, 444 775 with a 136.
Yeah.
Yeah, 136 PL. It's on the Aries standard frequency list, which, as you guys know, if you need to find that, that's always on the website here too.
It's a great list. I used it. It's fantastic.
Yeah, I strongly recommend. It's right here, the Aries standard frequency list under resources, and If you're in Lee County, I suggest you program your radios to this list. If you're everywhere else, I suggest you use this list to program your radios to make sure you got everything you need. But the one we're talking about is actually down here. It's the 444 775. It's right there. It's channel 34 on the area standard frequency list. We're kind of using that right now as like our talk around channel and our experimentation channel. No one's using it. We listened to it for weeks and no one ever uses it. So we are using it now.
Well,
So come talk to us on it.
let me make a suggestion if someone is inclined to look into the All-Star system.
Oh yeah, I love All-Star.
All-Star has better audio than Echolink, and you can put together as many different nodes as you want to and make a gigantic, ginormous, as my friend says, a ginormous net of whatever nodes that you want to put together. It's fantastic, and the audio is fantastic.
Ian, if you have any questions about building an All-Star node that's like really cheap, using Baofangs and stuff, you can talk to me because I've built one, and I've gone through the trial and error of building these things, and I know how they work. So hit me up if you need help with one of those.
Yes, let's put it up on All-Star and see if it works. I mean, it's all plugged in. I just got to download the software and set the sound card and press go.
Go to hamprojects.org for All-Star Link hardware.
Now, one thing to note is that if you want to run an All-Star node, they pretty much exclusively run on Raspberry Pis. You can connect on Windows to a node and talk in on the computer, but a Raspberry Pi is pretty much required to run a node. So you have to have a Pi, and then you have to have a sound card that will interface with your Baofeng radio. And you may have to actually build a custom sound interface like I did, using a base sound card and then actually modifying it and putting different components on it to make it work with a Baofeng. So All-Star won't really run on Windows like Echolink will. You do need a Raspberry Pi, as far as I know.
You can get a kit from that hamprojects.org.
It doesn't run on Windows?
The server software does not.
Oh, God.
Only the client does. The client.
You know what? Well, here's the way I look at it. If you don't want to work on my operating system, then I guess it ain't going to happen. No, I guess we'll have to figure that out because I don't have any Raspberry Pi stuff yet. But
I might just have to give you one of mine.
Echolink because Echolink was the easiest. Everybody's already using it. A lot, Charlotte County's already using it. It works great for them, and it sets up very easily. It's very easy to set up.
Hey, Ian, if you want, I can just give you one of my Pis. I have a ton of them, and I'll just give you one if you want, and then we can build the sound card for it.
All right, yeah, I would love to build it up. Let's build it up, and I'll set it up, and we'll get it going.
Are you using the onboard sound card, or
you have to buy a CM108 USB sound card, and then you desolder the actual audio jacks. You put on a transistor, a specific type of transistor. You solder it onto 3 of the pads, and then you run some resistors to different pads, and then you take a Baofeng 888S, which costs like $10 on Amazon. It's really cheap. And you actually solder a wire to the COS pin and to the PTT, and then of course the microphone and speaker. And then you run those wires over to your modified sound card, and you plug that into the Raspberry Pi. And the server software is really easy. You put it on a SD card, pop it into the Pi, and it already has drivers and an interface for that sound card built in. So it's actually really easy to set up once you've built the physical adapter.
Well, that's that. I will tell you guys, the one thing I do like about the system I'm using is the simplicity of it. I didn't have to do any of that. I got my Baofeng, you guys can see right here, and I've got my external antenna. This is hooked up to a little Yagi outside that I built. And this wire I bought from Baofeng for 10 bucks, and it's got the little piece on it. And then on the other side, it connects into my sound card, and that plugs into my computer. That's the entire setup. The radio's 25, the sound card's 8, and the cable's about 12. It's probably about a $40 setup, $45 setup. So I'm just showing you guys. That's a pretty easy solution. These sound cards are really cool. They make this one here, and they also make one that has the headphone and mic separately if you need that kind. There's 2 different kinds. And but that's all I did to set it up. I don't know how complicated I want to make it just to get a little better sound quality. On an FM radio, we're just talking on anyway.
Yeah,
So
it might not be worth it.
Yeah,
but you can connect this All-Star system. You can connect to other All-Star nodes, and you can still connect to Echolink nodes with it. So you may, I don't know, there may be some All-Star nodes that you're interested in connecting to that Echolink won't connect to.
Yeah, I don't
Other
know.
than that, it's
yeah.
It does have the well, no, you can do that on phone too. Never mind. Yeah, I guess the only real advantage is a sound quality.
Yeah. So I don't know. I mean, it's one of those things that the Echolink the Echolink sure has been easy up till now. So I don't know. Anyway, we'll have to see how that goes. All right. Anything else on that, guys? Anything else on any of that? I just want to let you guys know we were using that repeater and to give us a shout on it. We may even do some more stuff with that later.
But it seems to be very, very quiet. And there's no interference on it at all.
No, it's a very clear repeater, and it works well. It does obviously have some range problems, but I mean, out in Mid Cape, I'm able to get in with an HT. So I mean, it's pretty good. From my house up here, I can get in just anywhere on my property with my HT, even in my house, in my shed. I'm only about 3 miles away, but it's not a bad site. And the reason we picked it was we were kind of wanting to do something UHF because everything around here is VHF. And number 2, I listened to it for weeks and never heard a thing on it. It's dead. So why not use it? I think the electric cooperatives, the ones that put it there, it's not listed as a club repeater or a private repeater or a county repeater. So I don't know. I think it belongs to the co-op, but I'm not sure. I'm trying to find out. But either way, it's an amateur radio repeater. We're allowed to use it. So let's use it. Do what?
I hope they don't object to us using it. But my feeling is you bring on a repeater to life, it's a big thing. Because we got enough repeaters sitting around here that are just quiet all the time. So,
yep. Well, I eventually want to connect a bunch of them up, but that's for another day.
Yeah.
Oh.
You're talking about the Aurora and everything. One of the things I have kind of kept my eye on is all this exploration of Mars. I believe they found Aurora on Mars and on some of the other planets as well. So it's not a phenomena which is unique to Earth.
Yeah, pretty much anybody that has an electromagnetic field, I guess, can have auroras. It's kind of the way it works.
A field and an atmosphere. You got to have an atmosphere.
Yeah.
An atmosphere and a field. Ian, could I share my screen and show you this?
Yes, absolutely. Let me see if I have to. Yeah, yes, it's turned on now.
Okay, here's hamprojects.org.
Mm-hmm.
And you can scroll down here. There's a number of different things which are a lot of fun, but they provide very inexpensive kits. And if you look down here at the Sherry or the Sherry Pie Hat, and let's look at the Sherry Pie Hat, because that's an all-star node basically in a single box. And I don't have any interest in this site other than I know the guys that do this. And
right.
If you go down here and look at it, it gives you.
Hey guys, somebody's TV's on or something. We're getting really loud TV. Okay, there you go.
If you scroll down here, it tells you all about it. And basically, that's an all-star node right there. Okay, it comes with a little antenna, and you plug in a power supply and your Ethernet connection to the internet, and you're all done. And if you want to connect this to a repeater, all you got to do is the same thing, but set it up so that it actually talks to the input and the output of the repeater. And now you've got an all-star node on your repeater. And you scroll down here, it comes as a semi-assembled kit. You basically just have to put it together. And
it only does 400 milliwatts though, max power.
Right, 400 milliwatts. So it's got to be somewhere near. But I have one.
With the right Yagi, that would work on the 775 from my house.
Well, you could point it at that way. But you kind of want to, before you put it on somebody's repeater, I don't know, you're actually opening it up to the entire internet. So you might want to check into that a little bit. But how I use it here is I have one in my shack on the shelf and all around my property for, a quarter mile, half mile, anywhere I'm at with an HT, I can get into the repeater that I have connected to through the Sherry. And of course, some places like in Wisconsin, they have linked repeaters all throughout the state. So you just go to one connection, one node, and you can talk to anybody in the state as kind of a calling frequency through all those repeaters. And then you can move off to another location and have a QSO or a more private conversation without talking to everybody in the state. But this one here is all in a single box. The other one, if we go back to the Sherry, then if you build a Sherry, now you're talking about two boxes that connect together. So basically, one is has the Raspberry Pi, and the other one has the RF stuff in it, and you can program it to any frequency you might want on 2 meters or 440. But anyway, I'm just I guess I'm so pleased with All-Star. I'm kind of an advocate for that. So let me stop sharing my screen here.
Nice.
How do I stop sharing my screen?
You hit your computer with a hammer.
Stop share. There we go.
There we go.
Yep.
All right.
Thank you.
Yeah. Hey, thank you. I appreciate that because I really haven't looked at all into that All-Star yet because, like I said, Charlotte Car. I work with cars up there in Charlotte County, and they use Echolink, and it works good for them. So that's the only reason why I have been playing with that. And yes, we are testing and working with stuff with a repeater. But if we were ever going to hook anything up semi-permanent or permanent, we'd have to get with the repeater owner, of course. I don't even know who to get to on this one, but we're going to figure it out.
The call sign of the trustee.
Yeah, that's where you start. But we're going to figure it out because I'm going to get with a couple of repeater people around town and see who wants to connect what with me because there's other stuff around here we can connect up together. So, all right. The next thing I did want to go back to the 6 meter and the Magic Band. I wanted to see if there was anything that anybody else wanted to mention or bring up about that.
I noticed it was open this past weekend.
Yeah.
The CQ Worldwide WPX CW contest, And so I went all the way up, made contacts on 10, 15, 20, 40, and 80. And I thought, well, I'm going to, even though it's not in the contest, I'm going to go up and listen on 6 meters. And sure enough, it was open as well. So we had a pretty good opening this past weekend.
Yeah, there was a couple of really good. There was even several good openings this last not necessarily the last 2 days, but 3 or 4 days ago there was some pretty good openings. I wanted to show you guys. I got it pulled up here. When the Magic Band opened the other day, let's see here. Let me pull that up and show you. When the Magic Band opened the other day, I screen captured this. And this is the actual, this is my actual screen. You can see I'm on 50.313. And you can see that there's a lot of traffic on there. Now, what I do is I split my audio into 2 different computers. And then I use a second computer basically because I want a full scale view of my waterfall. So that's what it looked like on my other computer, so that I can see the entire waterfall for going back, 8 or 10 minutes or so. That's a lot. And remember, that's with a tightly focused Yagi shooting just up towards the northwest. So, I mean, we're talking just a sliver of the pie here. So I was just very amazed at some of the openings we've had lately. They've just absolutely been amazing. Let's see here. The neat thing I like about it is, like I said, I'm able to actually go right in and look at, I can actually go right in and look at the 6 meter map and tell right where that cloud's sitting, because I can see people talking back and forth, all crisscrossing, all through that one area. And that's where your Magic Band opening is. It's literally just that easy. I've always just been very, very surprised at in the last 3 weeks how awesome it is to be able to swing my Yagi around, shoot it in that direction, because I see that I have an opening to the Midwest. I shoot it in that direction, and the waterfall lights up, and I make the contacts. It's absolutely amazing. Okay, does any questions or anything on the Magic Band? Okay. All right, let's open it up to anybody that has any topics anywhere. Any topic anywhere they want to bring up tonight.
I got one topic, Ian, that I don't know if anybody that's still sticking around can help with. But like I said on the net this morning, you got me all fired up about 6 meters. So my antenna, it's a mini whip that actually came in, so it's in the shack here. I loaded it up and hooked it up to my Yaesu 991A, and I had a pretty high SWR, about 5-to-1. And I hit the auto tune, which I've never had to use before. It does nothing. I was wondering if anybody has a 991A that actually uses the auto tune on the thing.
I can answer that, or somebody else can. I don't know. I guess I'll go. Those internal tuners on pretty much every radio, the internal tuner won't match anything above maybe a 1-to-2, or if you're lucky, a 1-to-3. If you actually want to match something that high, you're gonna have to get a proper external tuner.
Yeah, I do have the external tuner, but it doesn't even try. That was the thing. It's supposed to, when you push the button, it says the tuner's supposed to light up on the screen. It doesn't even do that. So I may have a register that's not set correctly or something.
So you've got an external tuner plugged into the radio, and the radio controls the tuner?
I don't. I'll pull the external out and hook it up, but right now it's not. I was going to rely on the internal.
Oh, so have you tried the external tuner right now?
No, I have not yet.
Okay, yeah. So the internal tuner, we actually have a slightly different radio, but we have the exact same problem. If it won't even try to tune it. Normally it's supposed to sit there and try for, maybe 3 or 4 seconds to tune. Ours will just try for 0 time. It'll just boop for half a second and just cancel.
Yeah,
So
see, this doesn't even
that's the
do
same
that.
thing.
It doesn't even acknowledge that I pushed the button.
Yeah, it's
Well,
just a
my
different-
ICOM, if it's over 3, if it's a wild SWR, it won't even try. It detects right away that it's wild, and it won't even try. If it's got to be under a 3-to-1, or my ICOM won't even put power to it to try it.
Yeah. So I did switch down to 20 meters, which I have my mag loop on, and I had probably a 2.5 or something. I mistuned it, and I hit the auto tuner and didn't do anything either. So I'm thinking I may have a problem with my radio or something.
Well, this whip antenna you got for 6 meters, is it made for 6 meters?
Yeah, it's tuned for 6 meters. It's a Shark hamstick 6 meter.
Well, that's where I would start then. If it's tuned for 6 meters, it should hook right up to the radio with a perfect SWR.
That's what I thought
You look
too.
at it with an analyzer.
Yeah, I'm going to do that next. I
Yeah,
actually
that's what
got
you
in the
need to
same
do
shipment.
next.
I got my vector network analyzer, so I'm going to play with that tomorrow too.
Yeah, see where you're resonant. That's what you need to do.
Yeah, I'm gonna tell you, it could be a bad coax, or something's not right, or you got a defective antenna, because everything I've bought for a specific band has and everything I build, of course, I cut it out to where it's just perfect on the SWR. If you're 5-to-1 on an antenna that was made for that band, I'd start with the antenna.
Yeah, I know. Well, this was just a quick fix to get on 6 meters in, because I'm planning on doing a homebrew 6 meter here. So
yeah, homebrew 6 meters are pretty easy because it's not that big.
Right.
It's not that long, and there's no special anything that's required. You can literally go coax right out to the 2 driven elements. There's nothing special to it.
well,
So-
I can't have anything outside. We live in a HOA, so I can't do anything outside. So everything's in the
Who
shack.
hiss? Sorry, I hate homeowners association.
Yeah, I know, I do too, but I live in one, so I got
They are the nemesis to amateur radio operators everywhere.
They're the real radio Nazi.
I
frequency
hate
Karens.
Karens, man. I hate Karens. Anyway,
Oh, that's my project. Well, that's my project as well as the exercise tomorrow.
yeah. Well, yeah, I would definitely see about that antenna. Maybe something's not screwed in all the way, or maybe there's an adjustment on it for different bands or something. I'm not sure what kind of antenna it is. So,
Oh, it's just a Shark hamstick, and maybe I put a ground plane up there or something. I've got it sitting in a normal mobile mag mount, sitting up high. So maybe I'll
okay.
put
Oh, if it's a mag mount, like a vehicle antenna mag mount, you're definitely going to need a counterpoise. That's probably part of your problem.
yeah. Well, I put a sheet pan up there underneath it because my 2 meter and my 70 centimeter is over here, and it's also got sitting on top of a sheet pan, and I have no problems with those two, bands.
But
Yeah, sometimes if the pan's not grounding to the magnet, sometimes you got to make sure that pan's grounding.
Yeah.
you also got to remember that the pan is going to be much smaller in relation to the wavelength of the signal at 6 than it is at 2 and 70 centimeters.
Yeah, you might want to try yeah, he's right. You might want to try, putting, instead of a pan, you may want to try just a cross of 2 wires that are like maybe 6 foot, 8 foot long.
Okay, I can try
like
that.
and then just put it in the middle of that.
You
Yeah.
look at it on an analyzer and see what you got.
Yeah, and that's the neat thing about the analyzer is you can actually try all this stuff in real time with that little VNA.
I know, it just came today. I'm looking forward to playing around with that thing.
It's a pain in the butt, but don't give up on it. It's a neat little piece of equipment.
Well, I won't give up on it.
Yeah. Well, I mean, it's a little pain in the ass. You gotta set this thing and do that and go here and set this and do that.
If you have a stylus, it helps to use the screen.
Well, actually, I downloaded the software, so I hooked it up so I can do it right from the PC here. So,
yeah. Do you know what I always used to use for a stylus on it? This is funny, but the antenna on a bow thing works really good on it.
Does it?
But yeah, But
Well,
anyway.
let me see. Let me see if I can
There
touch
you
my
go.
screen with it.
But it works. But yeah, that you definitely fingers don't work on that. You're gonna need a little stylus or something to touch that screen, and turn off the stuff you don't need. Just start with nothing but the SWR and work your way up. That's what I did.
It works.
See if your antenna's
Are you using your antenna? Yeah, it does work. That's what I do. Yep.
That's the first thing I did with my end-fed halfways. When I built my end-fed halfway, I wanted to look at it on resin, and analyze it before I did anything else, and I cut it to resin. That thing works beautifully. I've worked this past weekend, worked much of Europe and Haiti and Hawaii and a whole bunch of places on 20 and 40 meters for the contest. I was amazed. So it's not even that far, but it's not even but 15, 20 feet above the ground.
Wow.
This is not there's just absolutely nothing about this antenna that's in any way esoteric or spectacular. I didn't spend hardly any money on it. I, got a core, built the auto transformer and took me some telephone wire, built the antenna, and it works just beautifully.
Okay. Just so you know, Rick, your microphone is still muffled really quiet like it was the other day.
Yeah, okay. I'm just too far away from the mic.
Well, you had that really nice one.
We can still hear you though. It's just a little low.
Yeah, I need.
We turned it up, and then Ian blasts in here, but all we see is the top of your head too.
Yeah, okay.
All right.
There you go.
All right, we need to move a little bit. I can actually see my video, so there.
There you go.
All right. All right, guys. Well, listen, I'm not staying on till midnight tonight, so let's go right to the next thing here. I do want to just mention real quick contesting. Let's take a look at the contesting for this weekend. The 1010 International Open Season PSK contest. Does anybody know about that one? Now, is that the one you got to be a member of some club, some 1010 club or something? I went to do this one time, and you had to pay to be a member or something.
You probably have to have a number, and 1010 they have a number, and in order to get a number, you have to become a member, and that involves you have to make 10 QSOs on 10 meters, and get all them to send the numbers in or whatever. I'm not sure what the exact procedure is, but you make 10 QSOs and they give you their numbers, and I guess you send them in or whatever. But and then they'll send you a number.
Huh. But I think you have to already be a member to do this.
Yeah.
Oh, wait a minute. It's not necessary that the amateur be a member of any of the following to submit. So anybody can do it.
Yeah, okay.
It'd be a good way to get some 10-meter phone contacts if the magic bands open up. 10 will open up and you can get some that way.
Yeah.
But yeah, there was that one, and that goes on like all weekend too. And then there was Ken Ham contest. I don't know what all this stuff is. I don't know what any of this stuff is.
Yeah, I didn't notice a whole lot. You got the Kentucky TSO party.
Yeah, that 1010's interesting though. I might do that just because I'm wanting to get some more 10-meter contacts.
Yeah.
But that's all it looks like this week. Let's take a quick peek at next week. Next weekend. Yeah, this would be next weekend.
Yeah, it's going to be a slow until field day, I think.
Yeah, there's the June VHF contest. What's that? 50 megahertz and up, that could be good. Again, you know, if a magic band opens up, you can make all kinds of contacts on 50 megahertz. I don't know who to talk to on VHF. It's like, I've tried some stuff. I did make a couple of contacts one night on, I took my dual Yeagis for my VHF Yeagis and put them shooting north, and I left it on upper sideband all night, and I told it to alert me if it picked up any FT8 contacts, and it actually alerted me twice, and I ran to the radio and got it. So I've actually made 2 FT8 contacts on VHF and 1 on UHF. But that might have been a collaborative effort with somebody else. All right, I guess that's about it. I don't see much going on in the way of contesting. Anybody else have anything else? All right, I'm looking forward to field day. I like phone, and I don't get to do a lot of phone because there's nobody to talk to anymore on phone unless there's a contest going on, or unless you want to go up to 80 and talk about arthritis. You know.
I have one net that I meet with a bunch of guys in Atlanta on 80. The other one is if I'm on 80, I'm down the lower end on the CW section in the contest.
I like 80 for FT8, but I'm always surprised. I actually seem to get more distance on 40 than I do 80.
Oh yeah, I'm sure you will.
Yeah.
It's a lot better for that.
Yeah, and you would think, you know, oh man, 80, but I don't get the distance on 80. 80's more of 1,500 miles or less, where 40 I'm going as far as I can go some nights. It's crazy.
DX on 80, you need to have your antenna up like 65 feet high or higher.
Well, that ain't happening.
That's not gonna happen.
Not here, not right now.
No.
I got so much aluminum in the air, I don't know what to do.
Yeah, so I really have more fun on 40 and up than I do on 80. 80 is to me is just something to talk, get down and talk on the bands, and like I said, I meet a bunch of guys in Atlanta on Thursday night, and then you know, I go up there and we get together and talk. And then, like I said, I was on 80 the other day on the CQ Worldwide contest, but 80 is not very productive for contests. I made 5 contacts there, and I made about 40 on 20. So a whole lot more than that. So 40, 20 and 15 were a lot more productive.
All right, guys, I'm not gonna end the meeting right this second, but I am gonna go ahead and close out the live stream. If no one else has anything else, does anyone else have anything else they want to bring up tonight? Southwest Florida TechNet. All right, everybody, I'd like to thank you for coming tonight to the Southwest Florida TechNet. My name is Ian, KO4EFS, and you can send me an email at ko4efs@gmail.com. I encourage each of you to do that if you have any questions, suggestions, and if there's anybody out there that wants to come and co-host with me, bring a topic. I am new to this. I shouldn't be the one every week trying to come up with something because I don't know everything. So I'm asking for some of you guys that have been around a while to pick your favorite topic, get with me, and let's bring it together. It'll be fun. All right. Remember, I'm not an instructor. I'm a facilitator. I want to help you guys to bring everybody together. That's the whole purpose of the Southwest Florida TechNet. We're on every Friday night at 8 o'clock right here on Zoom and on YouTube, and we'll be back next week for another one. So until next week, everybody, have a good one. This is KO4EFS signing off for the Southwest Florida.